Good afternoon, ladies and gentlemen. Welcome back. So, last two videos we did the simple rotator script for the camera, and we got some movement going with the first person character. So now this time I want to go over the HeadBob script that they have and kind of explain in detail what it's trying to do. And, you know, your guy ragdolling his head while you're running around. Alright, so now what we're going to do is create a new script, and we'll just call it HeadBob. And we'll double click and open up that bad boy. Alright. There is going to be quite a few variables here, so let's go. Now, like in the last script, we went over the serialized field attribute. We're going to do the same thing with a lot of the variables in this class. So, serialized field. Go private, and this is going to be a transform, and we're going to call it head. So this is going to be the head of the character. And next, another serialized field. If I can spell it right, serialized field, private, float, HeadBob frequency equals 1.5, and that's just obviously going to be how frequent your dude bobs his head. And just give me a second while I apply the policy again for whatever reason. Alright. I just like things to look a certain way while I'm programming, so. Now, again, serialized field, private float, HeadBob sway angle equals 0.5f, and that's just going to be the angle that, you know, things sway at, like the name says. Serialized field, private float, HeadBob side movement equals 0.05, and this is going to be just, you know, how far the HeadBob moves from side to side while you're running. Serialized field, private float, HeadBob speed multiplier, and this is going to be a multiplier attached to how fast the, you know, HeadBob is going to happen. Basically, like as you're running, you're going to be moving faster, so the speed multiplier is going to be going up, and it's going to, you know, make your guy ragdoll a little bit more. All right, serialized field, private float, bob stride speed lengthen. Oh, not string, stride. And that is also 0.3f, and it's going to be similar to the speed multiplier, but it's going to be how long the bob is going to be based on, you know, how fast you're going. Alright, now another one. Serialized field, float, jump, land move equals 3. And this is going to control, you know, how much your bob is going to happen when you're jumping and you land. We want to make that private. Alright, and stupid IntelliSense. Serialized field, again, private float, jump, land, tilt equals 60. And this is going to be how much the camera tilts when you land from a jump or something. So now we have serialized field again. There's quite a few in this class. and we're going to create a audio clip array, and this is going to store the footstep sounds. So private, and we're gonna, so we may as well call it footstep sounds. Alright, and again, serialize field, private audio clip, and jump sound. So when you jump, we're gonna play that sound. And once again, serialize field, private audio clip, land sound. Now at this point you're probably asking, why in the balls do you have so many serialized fields here? Why don't we just make it public? And when you're working with a bunch of other people that might end up interacting with your class at some point, there's going to be certain variables you don't want them to screw with. So this just makes sure that they can't access them from another script, but you can still fiddle around with them in the editor. So that's the only reason why I do that. So, you know, quite a few here. A couple more to go. We're going to have a reference to our first person character. Oh, we call it FPS character. So character, and we're going to create a vector 3 called original local position. So this head bobbing is going to work in local space, and we want to make sure that we have a reference to the original camera's position. That way, once head bobbing stops, it can kind of move back into that position. Alright, float. Next step time equals 0.5, and this is basically just the time until the next footstep happens. So float head bob cycle equals 0 equals, and the way the head bob is going to work is it's going to use a sine function, and it's going to cycle through. It's basically going to increase, and it's going to move through a sine wave to figure out how far to bob and stuff like that. Alright, and we're going to create another float called head bob fade, and set that to 0, 2. Okay. We're getting there, guys. Soon. Still have some more variables to declare. There's quite a few here. Alright, so these variables are going to be for the spring calculations to figure out like how it's bouncing and stuff. So float spring position equals 0.0f. Float spring velocity equals 0.0f. Float spring elastic equals 1.1f. Float spring dampen equals 0.8f. Float spring velocity threshold equals 0.05 equals float spring position threshold equals 0.05. Vector 3 previous position, another vector 3 called previous velocity, and we'll set that to 0 just to make sure it's there, and bool previous grounded. Alright, so what do these variables do? Spring position is just going to be the position of the spring in the formula or whatever, and the velocity is going to be the same. The elastic is going to be the elasticity of the spring, so how much it'll bounce and all that good stuff. The spring dampen is going to be how quickly the bouncing stops. the spring velocity threshold and the position threshold is going to be a minimum value that once it passes that value, it's going to be it's going to stop. And we're storing the previous position and velocity and grounded just to figure out what the spring is supposed to start doing this frame relative to the last frame. Alright, so now we can actually start doing stuff. So we're going to start with our start function. And we're going to store the original local position. And it's going to be head.local position. Alright. And character is going to equal get component FPS character. Alright, so we're storing our local position and we're storing a reference to our first person character by using the get component. So it's going to grab the component on the game object. Alright, and what we also want to do is we want to check the audio property, and it's going to be an audio source. And an audio source is something that actually plays the audio. So we want to check and see if there's an audio source attached to this object, and if there's not, we want to add one, because that's how we're going to be playing our jump sound and our footstep sounds. So if audio is null, if there's no audio source attached to this object, our game object dot add component audio source. Alright, so if it's not there, we want to add it. Alright, and lastly in start, previous position is equal to rigid body dot position. And that's it for start. The rest, fixed update. So void fixed update. Alright. So everything is going to be happening in the physics loop. So vector 3, we want to create a variable called velocity, and it's going to equal our rigid body, its velocity, minus rigid body dot position minus previous position divided by time dot delta time. Alright, so we're taking our previous position and our current position, and we're dividing it by the amount of time our last frame took to figure out how fast we're moving in total. So if we moved like a centimeter from this frame to last frame, and last frame took a tenth of a second, we actually moved 10 centimeters, per second, right? So that's what this is getting. It's how fast we're moving and in what direction. Alright, vector 3, another one, and we want to call it velocity change, is equal to our velocity minus previous velocity. So we want to figure out how much faster we're going now or how much slower we're going now compared to how fast or slow we were going last frame. Alright, and then we want to set previous position is equal to rigid body dot position, and previous velocity is equal to velocity. Alright, so we calculated the new velocity and the new velocity change, and we're going to store the previous position and previous velocity for the next frame. Alright, now that we calculated that, we're going to start calculating the springiness of the head bobbing. So spring velocity minus equals velocity change dot y. Alright, so the spring's velocity, we're going to subtract how fast or how slow we're going in the y direction from it. Alright, and spring velocity minus equals spring position times spring elastic. Alright, so from there springs are boingy, so we're going to also minus. We want to make it snap back to the original position. So we're minusing the spring position, and how we're multiplying it by how elasticy it is. So if it's greater than 1, it's going to start shooting back even faster. If it's less than 1, it's just going to kind of. So, all right. So spring position plus equals spring velocity times time dot delta time. All right. So we are just adding in the spring velocity to the current position, and we're multiplying it by delta time, so that it's going to be just how fast. It's going to be just based on time instead of frames. So if we only had spring velocity, it's going to be increasing by that velocity every single frame instead of every single second. So the thing's just going to fire off instead of going smoothly like we would hope to with delta time. All right, and then we are going to, before I forget, something we want to add in between here. We did the elastic stuff. We also want to add in the dampening. So spring velocity times equals spring dampen. All right, so it's going to multiply itself by whatever value of spring dampen is. And then we want to add it to the spring position. All right, now we want to clamp the spring position. So mathf.clamp spring position, and we're going to use specific values here, negative 0.3 and 0.3. All right, because we want to make sure that it doesn't go too far. Because if you don't clamp it, if you start going crazy with your character, suddenly the head bobbing is going to go nuts, and it's not going to make any sense at all. It's not going to look realistic. So we want to clamp it between certain values. All right, now we want to check how fast it's going, and if it is if it's less than the threshold, we want to stop it and make sure that the spring position is back in its original position. So we check to see if the velocity is less than the threshold that we set. So to do this, we're going to go mathf if mathf dot abs spring velocity, and this gets the absolute value of spring velocity. So if it's -1, it'll return 1. If it's -2, it'll return 2. So it's just always going to return a positive value. And if that is less than the spring velocity threshold, and if mathf dot absolute value of spring position is less than spring position threshold. All right, so if both of these are less than the thresholds, we are just going to set it to 0. Spring velocity is 0, spring position is 0. All right. So now that we got that settled, we're going to create a flat velocity. And basically, all we're doing is we're going to take our velocity here, and we're going to flatten it on the y. So we're going to set y to 0, so you only get the x and z velocity. So float velocity, flat velocity equals new vector 3 velocity.x 0 velocity.y z, and we're going to take the magnitude of it. Alright, so we don't want an actual vector value, you want the magnitude of that the vector. because we're going to be multiplying it. We don't want an actual position from it. Alright, so now we're going to figure out how long we want the strides to be. So stride lengthen is equal to 1 plus flat velocity times stride speed length. Alright, so we're getting our actual velocity, and we're going to increase the length of the slide depending on how fast we're moving. Okay, and we're going to start increasing our head bob cycle. So it's going to be head bob cycle plus equals, and in brackets, flat velocity divided by stride lengthen, and we're going to multiply that by, need more brackets, time dot delta time divided by head bob frequency. Alright, so the head bob cycle is going to increase depending on how fast you're going, divided by the how long the strides are going to be, and we want to multiply that by delta time. And the reason we're dividing this by the head bob frequency is as the head bob frequency decreases, that's going to be how many times per second the head bobbing is going to happen. So like 0.5 means that every 0.5 a head bob is going to happen, so it's going to be 2 every second. So we're dividing by that delta time by head bob frequency. That way we get an accurate measure of how many head bobs there are going to be per second. Okay. Next is going to be a float called bob factor, and that is going to be the actual sine curve. So mathf dot sine head bob cycle times mathf dot pi times 2. Alright, so sine takes radian values, and so if you know anything about trigonometry and graphing the sine curves and stuff like that, you know that the frequency of a sine curve is 180 degrees, and pi is 180 degrees. So we're getting the value of the head bob cycle, multiplying it by a frequency, and multiplying it by 2. That way, as head bob cycle gets to 1, it'll go through a cycle. It'll go through 2 cycles. That way, it'll go one way and go the other way. That kind of thing. All right, and float, and we're going to do the sway factor, which is actually like how fast your dude's swaying back and right. So head bobbing is up and down, and the sway is going to be you're running side to side. So bob sway factor, and we're going to use another sine function. So sine, and in sine we want to put pi, so mathf.pi times 2 times head bob cycle plus 0.5f. Oh, times 0.5. Oh, plus 0.5f. Jeez, what was going on there? But basically, we're the sway of your dude is going to be offset a little bit from the bobbing. It just looks a little bit better, and otherwise we'd be having a consistent sway. This way we can kind of, it'll be offset a little bit, it'll look better. That's why we're adding the plus 5 here. Alright. Now, we're going to modify bob factor that we just calculated here. Bob factor is equal to 1 minus brain fart. 1 minus bob factor times 0.5f plus 1. Now, why in the butt would you want to do that? basically what we do is we bring it back into the 0 and 1 range, and it is inverted. Alright, and we're going to modify bob factor again, and we're going to multiply it by itself. And the reason we do that is we want to bias bob factor towards 0. That way the sway isn't consistent. It's kind of like it's a little bit slower at first, and then it gets faster, and then slow at first and faster. That's what we're doing. That's what this does. All right. Now we're getting there. Now we're going to create an if statement, and we want to check if we're going to go new vector 3 velocity dot x 0 velocity dot z dot magnitude is less than 0.1 f, and inside this if statement we'll do HeadBob fade is equal to mathf dot lerp, doing that linear interpolation again, and HeadBob fade 0.0 time dot delta time. Alright, so what is that doing? Basically, if the magnitude of the velocity, the flat velocity, is less than 0.1, so if we're moving really slowly, we want to fade the HeadBob back to 0 and kind of move the head back to its original position. Otherwise, HeadBob fade equals mathf dot lerp HeadBob fade 1.0 and time dot delta time. So here we're kind of moving it to 0 if you're moving really slowly. Otherwise, we're going to move it back to 1, and the fade is going to be, up to 1. All right. Now that we got that settled, we're going to create another float. So float speed height factor, and it's going to equal 1 plus flat velocity times, what is it called? What do we call that? HeadBob speed multiplier. That's what we're wanting. Alright. It's going to be 1 plus how fast we're moving in the x and z times our speed multiplier. And basically this is just going to be the exaggeration of the height of the bob. Alright, so now that we got all that junk said and done, we're actually going to start manipulating the position of the head. Alright, so let's create a float that's going to store the x position, and it's going to be minus HeadBob side movement times the sway factor. Okay, so it's going to be our HeadBob movement times how much we want the sway factor to be. Next we want to get the y position, so we'll go the spring position that we calculated, and times jump land move plus our bob factor times, give it a value of 0.3 times HeadBob fade that we just calculated times speed height factor. Alright. Actually, let's make this a variable as well that we can change. Let's go back up here and let's go serialize field private float. We'll call it HeadBob height and set that to 0.3. Let's just do it that way. That way we can actually change it in the editor. So change this 0.3 to HeadBob height. Alright. Alright, now we'll calculate the tilt. So float x tilt is equal to negative spring position times jump land tilt. And we'll go with z tilt. That's going to be going this way. Z tilt equals bob sway factor times head bob sway angle times head bob fade. Alright, so we got the position that's going to be, and now we have the tilt, so now we can actually assign those values to the transform. So we'll go head dot local position is equal to original position plus new vector 3 x position, y position, and 0, because we're not moving forward or back, just up and to the side. And then we'll set the local rotation equals quaternion dot Euler x tilt 0.0f and z tilt. Alright, so we're creating a quaternion out of a Euler angle, getting our x tilt, which is going to be this way, and our z tilt, which is going to be forward and back. Alright, now we got those set up. Alright, now that we have the actual head bobbing and whatnot going on, we're going to get the audio in there so we can get some basic audio playing. Alright, so we only want to play the audio if the character is actually on the ground. So if character.grounded. Alright, now we're going to create another if statement in there, and if he wasn't previously grounded, that means that he was falling and he finally hit the ground. So if not previously grounded, we're going to use our audio.clip equals land sound, and we're going to play it, audio.play. And we're going to set our next step time to head bob cycle plus 0.5f. Alright. And if he was previously grounded, so that means that if he was on the ground before and he's on the ground this time, then he's walking. So we'll go if our head bob cycle is greater than next step time is equal to head bob cycle plus 0.5. Right, so another half a second or whatever the head bob cycle is. And we're going to make an int, and we're just going to call it n because it's just a random number. We don't really need it for anything beyond this. And it's going to equal random. So we're going to use the random class and generate a random number. Random.range 1 and footstep. It's not showing up, so just go up here real quick. Footstep sounds dot length audio.clip. So we're going to set the clip of the audio source attached to this object to footstep sounds n and audio.play. Alright, so it'll just grab a random play. So this is just going to grab a random number between 1 and the length of our footstep sounds array, and it's going to set that random clip to our audio source, and then it's going to play it. So that way, not every single footstep sounds the exact same. And just to make sure that we don't have the exact same sound playing over and over again, what we're going to do is go footstep sounds n, so our little number here is equal to the very first value, and footstep sounds 0 is equal to audio.clip. Alright, so we're swapping them. We're putting whatever value this is, so it could be the first, could be the middle, could be the last, could be, you know, the 37th. We're going to set it to whatever the very first value is. So the very first in the array is going to now be here, and our audio source has whatever this used to be stored there, and we're going to put it back there. So we just kind of did a quick switch. All right, just so that the footstep sounds aren't the exact same every single time. All right, and then we're going to set the previous grounded to true because he was grounded. All right. Now, if he wasn't grounded in the, or if he's not grounded right now, if he was the last frame, that means that he jumped. So if he's previously grounded before, audio.clip is equal to our jump sound, and audio.play. And we're going to set previously grounded to false. Alright, so to summarize what this class does, we've got a whole ton of variables, and we're going to recalculate the spring position, so the springiness of the head sway. And then using some of the data from our head sway, we calculate if we want to make a footstep sound, or if we're making a jump sound, if he, if the character jumped, or if he landed, we make the land sound. All right, so this takes care of some super basic audio, plus we get a sweet head swaying kind of effect. So, and we got an error saying that a double can't be converted to an F. So where is that happening? We have, that's not what I want. Where is this happening? I'll double click on the error to open it up right there. Oh, right here, next step time. That should solve that. Since it's C#, it likes those Fs, can't forget those. And we have some more errors. Same error, different spot. Right here. Alright. Anywhere else? Nope. Looks like we're good. Alright. So, what we're going to do is we're going to turn off the one that comes with the sample assets, and we're going to add our own just to make sure that it works. So, we'll attach HeadBob, and a head joint is going to be this, I believe. You want to make sure? Yep. And our audio clips, where'd they put those? Audio, character, footstep. They use them all? Yes, they did. Alright. So, footstep sounds. We'll drag all these guys in here. And then jump sound. Bam. Land sound. Alright, everything else should be good, so now we can test it out. No errors, that's a good sign. And we're getting a head bob. I'll increase the size of this so it's a little bit more apparent. Apparently that's all I can increase it to, which is sweet. We'll just drag these editors over and get a bigger view. Alright, so now as we're walking, you can see there's a slight head bob moving, and if we hold shift to run, you see the head bob gets a little bit more apparent, and as you're running and jumping, you see the guy his head bobbing. Alright, so hopefully you guys kind of understand what these scripts are doing a little bit better. They're a little bit more usable to you now that they've been explained a little bit more in detail. And yeah, so that's all for now, and we'll see what the next tutorial has for us.